Wow. If there's anything harder than explaining Z offset at all to an owner of a CR6 printer, it has to be trying to get it done in under 5 minutes. I'm pushing 16 to 20 minutes right now and trying to decide what I should leave out. I just put up a video, couldn't have been a day or two ago. It was all about ABL, automatic bed leveling, which isn't bed leveling at all. It's bed tramming. But bed leveling is so much more colloquial. And embedded in there, I decided to toss in Z offset because, hey, it's just a menu function. I'm just trying to show you how to get around the menus. And it turns out I learned a lot about how you get stuck in a rut when you teach yourself things on the internet. Sorry, guys. By watching YouTubes. Some of us only think we know what we're talking about. And I swear, when I put that video together, I really thought I knew what I was talking about. But thankfully, one of the guys on the Discord was kind enough to find a way to say, I don't think so, without really ripping into it. And it was enough really to push me. I had looked from an engineer's perspective, which I are, looking at it from a logical point of view, I couldn't really believe that it worked the way I thought it worked. But somehow there I was, locked into believing that's how you do it. So with a bit of help and a nudge, I went back and I looked at it again. I found another blog that I thought did an excellent job of making the argument that I was wrong, and this is how it was, and I'd be much better off the moment I started believing what I should believe instead of what I did believe. So I've done that. I've come through the curtain, as it were. Veil is lifted from my eyes. I see the light. I'm going to put the facts out there as I see them. I'll do my best to make it clear and understandable and debatable. And if you find failings in the logic, if you can demonstrate to yourself that I'm absolutely wrong and it should be this way, please add to the debate, get your comments down below, and let's engage. Or come on over to the Discord and we'll duke it out on the bed leveling channel. But if it turns out I'm right and what I'm offering you works for you, you're welcome. I'm glad to finally be contributing on the right side of how Z offset should be done. At the end of the day, the numbers I'm coming up with are the same from the point of view that the piece of paper I used to work with, because I used to believe in paper, was roughly, let's say, 100 microns thick when squeezed with calipers or scraped with a nozzle. And the offset that I used to measure when using a piece of paper was roughly 0.15 millimeters. Now, without the paper, because I found a way to do it that is unique to the CR6 and seems to be the best way to get straight to the correct value, I'm getting 0.05 as my offset. 0.05 plus the 0.1 would be back to the 0.15, just to do the math. So I reckon the offset I'm finding this way I'm going to show you in this video, is just as valid as the offset I found using paper. But I can describe how to do it in a way that can only be done on the CR6, that I think everyone can learn and use. And I think this is going to be a breakthrough for folks like me who had significant problems getting the same Z offset twice. Offset used to vary plus or minus, gosh, negative numbers to double digits. It went all over the place. And I think part of that is a number of contributing factors on the printer itself. which do have to be controlled. That's why such a wide range of variability when I first got the machine. And partly the non-repeatability of a subjective judgment of whether or not you're scraping a piece of paper of the same thickness as last time, with the same degree of drag as last time, or not. And when you come to print, and you've added, let's face it, you've added to the base layer height, the thickness of the sheet of paper, we're thinking per slicer that we're printing at 0.2 millimeters, and in truth, we're actually printing at more like 0.3 or 0.3 something because of the thickness of the paper. Imagine what 0.28 must be. So eventually you're not going to get the adhesion. You're going to wonder why. You're going to get poor prints, failing prints, and each time you go back and check your offset, subjectivity is going to kick in, plus the biases, the source of biases we talk about here, and it's just going to be too difficult to be happy printing on your printer. This way, taking that additional 100 microns out of the offset value, I think your setup will be more tolerant of the other biases because you're already that much closer to the bed before you start suffering the impact of the biases. And I'm going to show you a few tricks or describe to you a few ideas for mitigating or eliminating the sources of bias that are also contributing problems for you. Overall, by the time you get through this, my goal is that it was worth the time and effort it cost you. Please don't buzz past the good bits. Leave you to figure out whether you have or not. I do see from the analytics that I post a 40-minute video and it gets 6 minutes of watch time. I see you. I know what you're doing. So folks who want to know every little thing should stick with the track the whole way. The guys who are looking for an answer, buzz to it. Giving you the timeline, got all the clues you need there. Scan the videos. Stop if you see something interesting. If we can engage you on what is Z offset anyway, where does it come from on this machine? Why is it so subtly different from all the other machines that maybe I've had before or the guys on YouTube are talking about? Why is this paper thing the wrong idea when it's right for everybody else? Not right for everybody else. Okay? Sorry for the long rant. Let's go! So before we measure and demonstrate what Z offset is, let's just have a quick chat about what we're talking about. Marlin is written for a large variety of machines, not just the CR6, of course, so it anticipates a lot of different geometries and probes and issues. And to generalize the software so that it can be used by all of us, it's normalized on certain concepts. And one of the concepts is offset, where offset is defined for Marlin's purposes as the difference on each of the three axes. So there's an X offset, a Y offset, and a Z offset in Marlin. And in each case they represent a distance between the tip of the nozzle where the filament's going to come out and lie on your print, on your model, and the tip of the probe where the probe decides it has detected the bed. So the probe in automatic bed leveling systems, all probes, and there's many kinds of probes, but all of the probes are intended to tell Marlin Z equals 0 is now. I, the probe, have now detected Z equals 0 right here. And Marlin is programmed to, according to the machine that it's been configured for, to know how the bed is actually detected, with what type of probe, because each probe has its issues and its vulnerabilities and their expectations of it. So it knows which kind of probe you're using, and then it knows what parameters govern the accuracy of that probe and what matters, and it uses the offset information to protect you, so that, let's say you're using a BL Touch, which is a servo-driven probe. It's got a little pin that projects below the tip of the nozzle when it's looking for the bed, and then pops up above the height of the nozzle when it finds it. Because you don't want the probe dragging across the bed while you're printing. You need to be able to lift it above the level of the nozzle when you're printing, but you need it to hit the bed before the nozzle does when it's coming down probing. Right, makes sense. So those of you who haven't seen a BL Touch before don't know what I'm talking about. If you look one up now, it'll make more sense to you. With the CR6, there is no difference between the tip of the nozzle and the probe in the X and Y directions. And that's because the nozzle is the probe. That is not always the case on other printers. But when it comes to Z, even though the tip of the nozzle is what's hitting the bed, when it decides, oh, zero's right there, the way it detects that it has hit something is of necessity going to cause it to go past that thing. And it goes past that thing in the Z direction by an amount which is termed offset. So how does it do that? Well, you'll recognize the daughter board. Right? The daughter board, which is that component there on my printer, is plugged into a sensor right there on the edge. It's plugged into this bracket, right, which on a stock hot end Creality CR6 is where you mount the hot end, and that bracket, my machine, where you're looking, is just a little off screen almost. It's right there. So I have a hot end adapter screwed to my bracket. You, if you have a stock machine, actually have your hot end screwed to the bracket. And I'm calling it a bracket, this whole assembly, this silver thing. And in the center where your hot end's attached is shaped a little bit like a diving board. It's got a cutout to go around the nozzle, the hot end inlet. Right? It's got a cutout to go around the hot end inlet. But it is basically a lever. It is a diving board concept. It's free on the left there. It's not attached to anything, so it can bend. It's attached on the right. You see that great big blob of glue with wires coming out? Underneath there is a resistance. If you look up Wheatstone Bridge on the Wikipedia, you'll get a concept art. And what they're doing is measuring across the bridge for voltage changes as the resistance of the bridge elements change. So fancy engineering speak for, if you bend this thing, a signal will come out. And the signal comes out on that connector, which is then connected to the daughter board. And on the daughter board, there's some firmware, the design of which Creality has not released, so we have to guess. But logically, we suspect what it's doing is the larger of the two chips is actually like a digital scale. So it looks at that resistance and it's programmed to translate the readings that it sees into how hard is the nozzle pressed into an obstacle. If it's floating free, it's not pressed in. If it's pushed up against the bed, it's definitely pressed in. Has it been pressed in hard enough to declare that we're actually pushing through any molten filament that might be residing on the nozzle and pressing against the bed? The chip to just the small one there, the one you can see now, that's an STM32, much like the one that's on your motherboard. It's programmed to look at a value with an ADC, analog to digital conversion function, built into that chip, wired to the output of this potentiometer. So really hard to see with the big fat thumb there, but just to the right of the screw hole, there's a screw, you see? That's the top of a potentiometer. It's labeled RP1 on the daughter board. That one sets a value into the, sends a value into the processor, the ADXL thing here, the gauge reader, the strain gauge reader sends a signal in, and the software in there does something to compare the two and make a decision. And when it makes the decision that, yep, that's the bed the little blue light comes on and it sends a signal down to Marlin saying we've hit something. And Marlin was programmed to understand that the optic switch says either the probe is active or it's not. If the probe is active, listen to that signal and understand that as ZN stop, switched on, active. If the optical switch probe is not active, ignore what's coming from the nozzle probe because it doesn't matter. It's probably printing and banging into things and it's irrelevant. We're not looking for the bed right now. So that's the importance of the optical switch. But there's a really high level discussion. So now what happens, suppose I pull on the hot end instead of pushing. The design of the circuit has not really taken good care of that possibility, we think. Again, we don't know what the firmware is, so we have to guess at what it's good at and what it's not good at. But based on observation of printer behavior, it does appear that if you pull on the filament that's going into the hot end, or you pull on the Bowden tube that's connected to the hot end, it's the same as pushing on the nozzle. As far as the diving board's concerned, it can't tell the difference. The diving board does not know whether it's being pulled up or pushed up. It just knows the resistance changes when the diving board is strained. And the way in which it changes, if you strain it down, the signal is such that the processor does not interpret that as touching the bed. But if you're pushing it down the whole time that it's looking for the bed, you in effect have biased the reading. So it's going to take longer, it's going to take more upward force on the diving board to compensate for the downward biasing strain. So you're not going to detect the bed as soon in your travels as you would have. So you're going to be further down before the bed signals, oh, we've hit something. If you're pulling, if the Bowden tube is pulling off to the right, if you're facing the printer, and in effect pulling up on the strain gauge, then it's already predisposed to going, oh look, there's a bed, even if you're in mid-air. You may sometimes see when the head is slewing from side to side, the little blue light's flickering. It's because the strain on the top of the hot end is telling the gauge, hey, the diving board is bent, we must have hit something. And even if you're not working with a direct drive machine, where the direct drive has got a grip on the filament, if I pull the filament I can't help but pull on the extruder, it's going to influence things. If I have a Bowden tube there and a filament pushed in, if the filament has any stiction whatsoever, if it's touching the cold zone or the hot zone and it's gluey and in pulling on it there's resistance, that resistance will translate into an upward force on the nozzle. So pulling on the filament will influence where homing thinks is bed 0. It will influence ABL if you leave those things in there when you're running ABL. It will influence Z offset measurement if you leave those things in there while you're measuring Z offset. Your best bet is to measure bed mesh and bed offset with filament and tube out of the system. No opportunity to put any strain whatsoever on that diving board that is not a consequence of the bed pressing on the nozzle, and speaking in relativistic terms, or in fact the nozzle pressing on the bed, which is what is actually happening in your world. Long story, can't make it shorter and still get the point across clearly. Understand that every time you print, your nozzle has to find home first. Even though you've already calibrated the mesh, you've already calibrated Z offset, the printer will once again give itself an opportunity to make a mistake. It goes to the center of the bed and it says, where is home? Because otherwise it's not confident. If you switch power off and on, the firmware authors did not know whether you had moved anything between the time you switched off and switched back on. They insist on being told all over again, where is 0 please? So you have to run G28 anytime you've switched the machine off and back on, and at the end of a print You might pull the bed forward to pull the model off. You might push it back. They don't know what you've done because there are no sensors that tell them if you've moved the bed or the gantry. They don't know. So they insist G28 before print in order to locate themselves reliably within 10 microns of the bed and so on, 20 microns. So in all fairness, we need to let them do that, but that means we're exposed to the risk that the offset has a bias added to it by the homing process if there was any strain on the diving board that was not a consequence of the nozzle pressing to the bed when asked. Residual filament on the end, residual filament lying inside and pulling on it while it's going, vibrations to some extent, the electrical interference that might get in there from the fan and the heater onto the sensor wires. We deal with what we can. We turn off the heaters while we're probing to minimize that risk, but you're the only one who can manage the other risks. Don't clip your wires together on the nozzle. It pulls at the hot end. It pulls them all towards the daughter board, which leverages the diving board upwards and predisposes it to triggering. Don't mess around too much with RP1, because as often as you do that, you change whether the gauge is even working within its linear range. You don't know that the processor has enough margin in the firmware to tolerate you moving things around in the settings outside of Creality's design limits. It's all risk. Right? And when you're running the stock firmware, Creality expects much higher activation forces and different activation speeds on things, so it may be more tolerant of these mistakes than the community firmware, which was fine-tuned and optimized by the devs to get the absolutely best precision in the probing. You need to do your part and avoid all causes of bias and strain if you want the firmware to do well by you. Wow, that was a rant. Let's get on with actually measuring offset, and I'll talk about how that worked too. So if I go to the Z offset menu, the leveling menu, and I press home for Z offset, the carriage goes off to XY0 and then it comes down to the bed. Once, twice, goes to 10 the second time because that's the end of probing, and then it drops to 0. And at that point it believes it's touching the bed. Now, if it was touching the bed and the blue light was on, we would know it had gone past 0, yes? As soon as you push the nozzle into the bed surface, because it's mounted on that diving board of a bracket, the diving board bends up because the nozzle, in theory, can't push the bed down, but the bed can push the nozzle up. So the diving board bends up, the strain gauge says, hey, we've hit something, and the machine says, oh, that is the bed. But by then it's already deflected the diving board up. So at that point, Z axes are already below the level of the bed, and it needs to release that strain to be back up at 0. So I'm sitting on the bed, you're looking at the blue light, it's just above the mounting screw on the dashboard. Now I've reduced my offset by 0.1. Still no blue light. 0.02, no blue light. 0.03. 0.04. 0.04 before the blue light came on. At that point we know we're too low because we've managed to bend this thing up again. If I go to 0.05, my light goes out. So I'm really borderline. The camera is not able to record the sounds I'm able to hear. You will be able to hear your own printer. When you hear the fan noise, buzzing on the bed, it's because the vibrations of the cooling fan transferred to the nozzle are now being transferred to the bed surface. So you're hearing it, you'll hear it buzz. Now you know it's touching. If you just lift it above that so the buzzing stops, or you leave it just where the buzzing starts, you're as close as you're going to get manually to Z actually equals 0. So I had a Z offset of 0.08. I'm presently looking at 0.05. Through messing around, I've established there's at least, let's say at least, a hysteresis here of 0.01. So plus or minus one digit, like all digital measurements. I can't get any better than that. I'd rather have the light off than have the light on, but I've come down now by 0.03 points. So I'm at least 0.01 off, even if 8 should have been 7. I'm still, let's say, 0.02 or 0.03 off where I was before. I'm interpreting that as Z offset has changed since last time I measured it. So I have to think for a while about what could possibly cause Z offset to change. What creates the offset in the first place? What can cause the nozzle on the CR6 printer to go further before detecting the bed than it did last time? I've set it to 0.05. Let's do this again. I'm going to hit home. It's lifting the nozzle. It homes it to XY as 0, brings it back to the center of the bed, and it looks for the bed. Found it once, found it twice, finishes probing at 10 millimeters, drops to where Z equals 0. The blue light is out. 0.04, the blue light is on. 0.05, the blue light is out. Now, as it happens, right now I'm running the community firmware. I also run Clipper on this machine. And without really knowing why, I have learned over time that the offset, when printing Clipper, I set the offset to what turns out to be 0.04 millimeters. And here, the community firmware has agreed with me, but it's done it in independent fashion, let's say. So, if I lower this to 0.04 while I'm listening to it, sorry that you can't hear the same buzzing with this camera. Yep, it's extremely subtle. I'd have to argue for it, and some people would say it's my imagination. But I believe I'm right at the threshold. And 0.04 is the correct offset. 0.05, I've raised it so the light goes out. So interesting technique. You are most welcome to try it on your own system and give me feedback as to how it works for you, and argue with me if you think the logic here is flawed. I'm still not clear why it went from 08 to 05 from one measurement to the next, because in both cases, plus or minus 0.01 put the blue light on or off. Now I'm going to run offset, home, up she goes to the 10 millimeters. Home's XY 0, back to center of the bed, looking for Z equals 0. 1, 2, Now if it drops, light's still out at 0.05, 0.04, 0.03 to get the light on, 0.04, 0.05 to get the light out. So you see the hysteresis there of 0.02 between get the light on, get the light off, get the light on, get the light off. So I'm going to leave it at 0.05, and you could argue 0.04 is even better, but we haven't seen it print yet. Now I'm going to put the filament in. We're going to print a validation pattern. So this is the plugin I'm going to use by a fellow called CR6 or 5 Axes, and you could come to this address, select add to Cura, and it would go into yours too, or you can just use the marketplace button here, navigate to it and find it there. It's a very popular plugin. It has a lot of different calibration tools that you can install very quickly. So I know a lot of you like to use temperature towers, retraction towers, whatever. You're going to appreciate having this once you discover it. It also has flow tests in here. And the bed test, calibration test, is off the screen on this particular pop-up, but it's in the tool. Having already installed it on my system, I can go straight to extensions and parts for calibration, scroll down to where I now know that to be right at the very bottom of the menu, add bed level calibration. And there you go, there's the pattern with 9 squares and lines joining them. I want flow. I'm going to filter on flow. And Cura will filter down to only displaying the parameters in which flow is a factor or gets an honorable mention. Now I know I'm looking for the material menu and flow on here. Yes, it's retained my last edits. So here is the flow parameter. You'll notice this pop-up on the left because I keep, well, it disappears if I try to show you. So I have another extension plugged in here, which is a help function. It's an excellent tool. It gives you a lot of detail, parameter by parameter. What will happen if I choose it? What's the point of it? Which other parameters are influenced by doing this? Very handy tool. That is settings guide. Okay, this one here. So look for that on the marketplace if you don't have it. It should be a default in everybody's profile. The one thing that's irritating about it is it does that when you don't mean for it to pop anything up. So you just have to live with that. We save the file there. Cura very helpfully offers to eject if I wish. I want to make sure it's actually there first. Untitled G-code. Okay, that's because I didn't save the file first and give it a name, and the extension plugin doesn't actually attach a name to the file off the get-go. But as long as we know it's called Untitled, I'll be able to find it when I'm on my printer. So let's use the eject button from Cura to remove the drive. I'll go over to the printer now and make this happen. I have flipped the bed from the powdered PEI surface to the smooth PEI surface, just to take away any risk that bumps and valleys in the bed pattern make a difference. You may see a scar in the center of this bed. I have been attacked in the past by this printer when it decided not to stop when the nozzle hit the bed. It's one of the vulnerabilities of PEI sheets, as they can be gouged and divoted by the nozzle on this printer. Now I am printing in PETG here, and I do have my leveling settings, which we looked at once before. What I want to do is fix this, otherwise what it's going to do is drop my temperature from 80, which I've preheat, to 55 while I'm trying to do leveling, and just mess the bed up altogether if temperature is indeed changing the shape of the bed. So I can leave that at 80. I don't really want to leave a parade of PETG dots on my bed as it goes around probing, so I'll let the nozzle temperature stay at 145. and I'll preheat that later. But I want to at least get the ABL measured at the intended printing temperature. Okay? The offset is still at 0.05, which I won't change for this test. So that's the whole point of the test. Let's run bed leveling like that. So it's zeroed everything out. And it's going to wait till it gets to 80 to begin the test. So there's your bed mesh, ready to go to print at that temperature on the bed. Remember, my experience on this printer has been that offset varies from time to time. So that risk is always present in my mind. So if I home using the Z offset button, again it uses the same leveling settings, so still too cold for the filament to be drooling. Two measures, drops to 0. If we reduce the offset by 0.01, 0.02, lights on, 0.01 up, 0.02 up, lights off. So now we're at that other broader hysteresis value. Again, I don't know what makes the difference of plus or minus 0.01 versus plus or minus 0.02 in hysteresis. That's still an unknown to me. But I'm still at 0.05 when the light goes out on the way back up, and that's good enough for me. So maybe there'll be as much as 0.02 error in the thickness of things to account for at the end, but close enough for this experiment. So now I'm going to go to set up and preheat my nozzle to the printing temperature, at which point drool is inevitable. Okay, so I have preheated my system to the 220 and the 80 that I want to print at. I can go to print. Untitled is what we call the pattern. The print menu says, "Are you sure that's what you meant?" And I say, "Yes, please." And it goes ahead and homes the printer and starts drawing the skirt. And now it's going to head home. You'll know if there was any drool because it will leave you a gift of poop in the middle of the bed. No, I don't think so. That's the scar that's in the PEI sheet. So we drew the purge line. It will now attempt to draw the skirt. I brush it lightly with my fingernail. It is adhered to the bed. That's a good first sign. I'll take the purge line out of the way just because it spoils the pattern. And it gives me a chance to confirm there is adhesion of the filament to the bed. I'm very impressed with all of the bonding of the lines. So what you see here is the slicer has drawn the walls around each square first, and now it's going to draw the bottom layer of each square, there only being one layer. We're not seeing any scraping of the pattern or places where it simply didn't print to the bed because there wasn't enough distance. So I like to interpret that as the offset is not too low. And there we go. So, camera's looking at glare on that pattern. Alright, so there are no lumps in the center of these squares the way there were in the center of the verification pattern circles. I think that's a consequence again of I'm drawing squares here, not circles. There's no reason to leave a scar. I can see the scar on the bed reflected in the print here. God bless plastic has molded directly into that little hole and left an artifact there, so I can't use that as any indication of problems. I don't see any bonding issues on the lines. I'm going to lift you off the tripod here. Sorry for the noise. And so there's the quality of the squares and the lines. Nicely spaced, nicely bonded. There's the scar from the bed. Sorry for the poor lighting. Hopefully that satisfies your curiosities, and now the acid test will be, what does the caliper say? Okay, so there's the pattern that we printed. I did mention while I was babbling away that if you peel the skirt first, I've let the bed cool. You see the skirt coming away as a single bonded product and not individual threads. That's our first good sign. You should not be able to push this apart into separate lines. It should all just act as though it's one printed piece, even though it made 3 passes to draw this skirt. I have had prints in the past where this came away as 3 separated threads, even though it looked alright on the bed. And I take that as a sign the lines didn't bond correctly, which can mean you're printing at too far away from the bed. So the inverse ought to be true, right? This should be a good sign that we printed at a good distance from the bed because the lines all fused. We were not too high. It doesn't mean we weren't too low, but it means we were not too high. Now, calipers here, digital calipers, God bless them. Zero that there. .13 it says, which is clearly less than 0.2. Same there. So 0.13 thick so far. Oh, I've messed up my calipers. Don't know how I do that. So we're 0.13, 0.15. That's less than we'd hoped for. 'Tis what it is right now. May indicate my flow setting was too low after all. And we want to peel away the pattern. I let the bed cool before I came back here, so I didn't want to deform the squares too badly as I peeled this away. The lines and the cooler bed allow me to peel this off without distortion or damage. Let's just have a look before I lose control of which way is front. I read right across the square. Ooh, look at you. 0.22. On the line. No, I've lost it again. On the line before the square. 0.16, just like the skirt, but on the square itself, how does that get? On the square itself, 0.23. That again could be the top and bottom lines, not the walls. Let's try a couple of others. 0.25, 0.26 even, 0.24, 0.29, 0.28, 0.24, 0.24, 0.26, 0.25. So, fairly consistent, within plus or minus 0.01, 0.02 around the whole circuit. We said plus or minus 1 digit error possibility anyway, so the 0.01 really is statistically insignificant. I think I'm going to find that flow isn't quite, 0.96 may still be a tad high on this filament, but not to make too many excuses. I think there's an accumulation of errors here also between homing, the probing of each point. Both of those could be off by 0.01, which is 0.02 worst case stacked against me, or cancelled out if it goes t'other way for me. If the hysteresis was 0.02 at the time, then that would account completely for the 0.04 error in this term. I'm arguing really that there's a limit to how precisely, I should say the other way, there's a limit to how accurately you can set these points. There was a time when Creality was first selling these printers, they had the firmware set so that you could only change offset in 0.05 millimeter increments. Maybe they knew something that I'm still learning. But 0.2 is what I asked for. 0.24 seems to be what I got. When you're building things where the dimensions have to be absolutely critical, that argues you're going to still have to test, adjust things for your particular printer's performance to get to the dimensions you want. You can't just fire and forget. But the offset setting method that I've offered you here, I think, is vindicated by this pattern and the results we got. So please share what results you get and how you came about testing this. And if you gain any more insights, by all means, let's pool our knowledge. And I'm quite happy to reiterate this thought process if it turns out there's something I've overlooked or not considered that someone brings forward for me. Enjoy your printer. Don't get lost in the numbers too badly. But here is your answer for how do I get the offset correct, using the fact that the printer itself can tell me when it's touching the bed and when it's not, instead of trying to shine a light behind the nozzle like some people have to do on other models of printer, or instead of using a feeler gauge and subtracting the thickness of the feeler gauge from wherever your offset says you are. Try this. I think it works. Bye-bye. So what do you think? It's still got a little bit of variation in there, but I'm getting very clean print. I should probably now, I'm going to stop the video here, promise. I'm probably also going to get around to trying the other advice I've had that says, now print a layer like that and get your calipers out and see how thick it is. I may also be take a deeper look at bed surface variation. Notice I did that whole thing with a powdered PEI bed, and maybe it turns out that the peaks and valleys on that bed, plus a little bit of gouging that my printer has executed on the bed once in a while, is making a difference. The difference in hysteresis is real. I see that also when I'm calibrating with the scale, and I test for activation and deactivation force, and the range and spread of values will vary from the beginning to the end of an individual test. So I get the feeling that there's something, or more than one thing, in the system that fatigues if you repeat your trials too close together frequently. And all of this mystery still. I don't profess to understand completely what's influencing offset and variation on the machine. It's a surprisingly deep puzzle. For those who are curious and haven't heard the term before, look up Dunning and Kruger in Wikipedia. The less you really know, the more you think you know. Vice versa. So, I know just enough to know that I don't know enough, but I've shared with you the best I can do right now. You're welcome to it. Please help me contribute and build this knowledge so that we can all master offset and bed mesh on this machine to the best of our abilities. Sure, there are other influences I've overlooked, and there may be flaws in my method. Very open to feedback, comments below. Use the likes and unlike buttons. I've left a whole lot of outtakes on the bottom of my editing floor, so it may turn out there are more spin-off videos to come. This one, God bless you, is done. See you again soon. Bye-bye.